A polyhedron is a 3D shape with polygons as surfaces. So this is a polyhedron. Each polygon is a face. So these are called faces, top, bottom, left, right, middle. An edge is a segment that is formed by the intersection of two faces. So this is an edge, 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 edge. A vertex is a point where three or more edges intersect. So these are vertices. In example 1 lists the vertices, edges, and faces of the polyhedron below. So the vertices are the points where three or more intersect, three or more faces. So the vertices are the points H, D, E, F, and G. The edges are segments. So these red segments right here that would basically trace the entire figure. So the edges are EF, ED, FG, etc. And then the faces are the polygons. So remember, you name polygons without putting parentheses in between. So this face is the face HDE. This triangle is HEF. There's another triangle on the back side that's HGF. There's a triangle on the left side, it's getting messy, that's HGD. And then don't forget about the bottom square, or we can't really, I guess we don't know if it's a square, but that's GEEF. Euler, so even though this looks like Euler, it's pronounced Euler. Looks like that. Euler's formula for the relationship among the number of vertices, edges, and faces is the faces plus the vertices equals the edges plus 2. So the F plus V, so vertices plus faces has to equal edges plus 2. So in this case, this one needs to be 4. So 4 plus X equals 6 plus 2 if I write it out. That's this line. The second line is going to be X plus 6 has to equal 12 plus 2, 14. So that's going to be 8. This one, vertices, 6 plus faces, we don't know, X equals 12 plus 2. So this one's 8 as well. So use this formula. And then beginning of the year we did nets. So a net is when you take apart a figure and flatten it. So a net is a two-dimensional representation. So the net that matches up with this one is right here. This is a pyramid. So it has triangle faces and a base. That's a rectangle. So it's right here. This one has two bases that are pentagons and rectangular faces, and this one, triangular prism, is right here. A cross section is the intersection of a solid and a plane. So think about taking a saw and cutting through this triangular prism. What would the shape be? The shape, if it's parallel to the base, would be the same as the base. So this would be a triangle. This is cutting parallel to the bases. So this would be a rectangle or a square. We don't really know for sure if it's a square because we don't know if all sides are equal. And this one looks like a square pyramid, but we're not sure, so it would be a rectangle. And now we're going to draw each cross section. So a vertical plane intersecting the front and right face of a cube. So I'm going to draw a cube first. Draw the shape first. This is the front, this is the right. So a vertical plane, so it's going up and down, and it's intersecting the front and right face. So this shape is going to be a rectangle. A vertical plane intersecting the top and the bottom faces of a cylinder. So I'm going to draw a cylinder. So it's a vertical and it's intersecting the top and the bottom. So this is going to make a rectangle. A plane that is parallel to the bases of a cylinder. So again, you're going to draw a cylinder parallel to the bases. So this would make a circle. If it wasn't parallel, it would make an ellipse. And then a plane that is perpendicular to a square pyramid. So I'm going to draw a square pyramid. Oh, it's perpendicular to the base and intersects the front and right left back corner. Ooh, front right, left back corner. And it's going side to side. This one would be a trapezoid. So I'm looking at my notes that I wrote before. So if you're looking at the notes online, I misread that it was parallel. So notes online look like this, and that would make a square.